Hello and welcome. This is Rick, and right now I'm wearing a pair of Fire Engine red penny loafers for those of you interested. Today we're going to talk about inverses. Inverses really comes from the idea from Latin where we are talking about going back. The word in Latin has the idea to turn around or go back the other way. In mathematical terms, we can really think of this in the problem-solving idea of recasting, which is the same idea as point of view. From whose point of view am I going to look at this problem from? So let's take a standard pretty simple equation here. You should recognize this as the equation of a line. F of x equals 3/4 x plus 5, and we know f of x we can oftentimes just think of as our y. It's our other variable in the equation. Okay, so if I wanted to look at this from another point of view, the natural point of view that I'd want to look at really is from the variable x. Right now I'm looking at this from the point of view of y. I'm looking at y as a function of x. Well, what does this look like from the point of view of x? And so the way I would look at that is, okay, well, let's just solve it for x then. So to solve this for x, I would subtract 5 from both sides. I'd multiply both sides by 4/3, and I would end up with 4 times y minus 5 over 3 is equal to x. And so now I have the point of view of the equation from x, and we would think of this as the inverse of this function f of x. Now, of course it's mathematics, so we have to have a special way to write this. So the way we write this in mathematics, the inverse of a function I write with an exponent of -1. Now, some of you will remember that when you see things like 5 to the -1, you're thinking of 1/5. Well, think about that for a minute. 1/5 is the inverse, the multiplicative inverse of 5. 5 times 1/5 gives me the identity of 1 under multiplication. Under addition, if I was going to talk about the addition inverse, then 5 to the -1 would be equal to -5. Now this is a little bit different idea. Don't get too whacked out or weirded out here. This is just saying that -5 is the additive inverse of 5. Because 5 plus -5 gives me the multiplicative, or the additive identity of 0. Well, going back to function notation, this -1 up here, this notation means that this is the functional inverse of f of x. So, f of -x I'm going to write as 4 times x minus 5 divided by 3. Notice I've done this is the closest I will come to calling this magic in math. I've just switched y and x because I want the inverse function to still be in terms of x. So all I do is I say, okay, this function x is really an inverse function. I want to write it of x, so I'm going to switch the y and the x around. Perfectly legal, perfectly okay, perfectly normal. And you'll find something really kind of neat happens here, that when I substitute this inverse, so I'm going to take f of f inverse of x, and remembering from our function notation, this means f of 4 times x minus 5 over 3, and I'm going to substitute that back into my original equation up here. Remember my original equation of 3/4 x plus 5. So here's what we're going to do. I say okay, 3/4 times 4/3 x minus 5 plus 5, and of course 4/3 times 3/4, that multiplies out and I get x minus 5 plus 5, and that gives me x. Notice I'm right back down to where I started, that value of x. Now take a look at what happens if I run this the other direction. Let's take f inverse of f of x, and that would give me, let's see here, so I'd have 4 times x, and in this case my x is f of x, so that's that 3/4 x plus 5. So I'm going to write 3/4 x plus 5, because this whole piece right here is f of x, and the whole thing is going to be, where are we? Oh, I have to get my equation right here. So I'm doing f inverse of f of x, f inverse is that. Okay, so x, I'm going to do this minus 5, and the whole thing is going to be over 3, and I need one more set of parentheses here. Okay. So I've taken my f of x, I've plugged it in for x from this function up here. Okay, there's my f inverse of x, and this whole x right here, okay, notice what happened. Okay, that whole x is f of x. I plugged that whole thing in for x. Okay, so let's continue on. I've made a substitution. So what's going to happen here? Well, I've got 4 times this whole thing. So let's see what happens. Well, I have 4 times 3/4 x plus 5 minus 5. So that's just going to give me 3/4 x all over 3. 4 times 3/4 x just gives me 3x over 3, and that just gives me x. So what's this magic thing that's just happened here? Well, I see that f of f inverse of x is equal to f inverse of f of x, and they're both equal to x. So the inverse has undone the function has undone the inverse, and it just leaves me with x as the answer. One other way that I could look at this. One other way to look at inverse is to look at it from an English perspective. Okay, so we're looking at our inverse, and so this says f of x is equal to, okay, some stuff in x. So it's saying if I know x, what is f of x? Okay, that's my original function. Now the inverse function, if I relate it back to this original idea of the function, it's asking the question, if I know f of x, what is x? And again, this is coming back to the idea of the recasting. different point of view. The inverse is dealing with the same function, but it's just looking at it from the different point of view. The f of x says, I know x, what's f of x? The inverse says, I know y, what's in x? But since we're dealing with algebra, we're dealing with college algebra, we're going to put this in terms of f of x. And that's why we have this special property of the inverses, which says f of f inverse is equal to f inverse of f of x, which is equal to x. So it says, okay, if I know x and I plug that into f inverse, it's just going to tell me, okay, if I know x, it'll give me what f inverse is, which comes back to my idea of, all right, I know what x is, what's f of x, and it's going to bring me back to that x thing one more time. I'm just looking at the same equation, the same function, I'm just looking at it from two completely different viewpoints. If you want to play with this from a very visceral, physical end, lay on the floor and look at the ceiling, and then stand on a chair and look back down on the floor. You're looking through the same space, you're looking through the same things, you're just looking at it from a different perspective. Or go in a room that has two doors, say, the door into the room and a closet. Look at the room from the door into the room, look at the room from the closet looking back to the door. You're looking at the same room, you're just looking at it from a different perspective. And that's what inverses are all about. We're looking at the same function from a different perspective, and mathematically speaking, it's always going to say, you know what? We are looking at the exact same thing. We're still looking at this value of x. So, have fun with the inverses, and if you have questions, you still know how to get a hold of me. Good luck.